We are continuing on with our Red Hat AI Combinator Hackathon entry for code generation. And we're going to load the code search model into the Solar search engine. In this hackathon, we'll be generating code with AI/ML provided by the well-established Computate project for generating lots and lots of code. We will automatically generate OpenAPI specs, database table schemas, Java plain old Java objects, Vertex reactive Java APIs, handlebars HTML page templates, JavaScript page and API functions, NJSI LD context data, OpenShift custom resource definitions, and Ansible operator roles and playbooks for any of the hundreds of open source edge device Fireware smart data models to be deployed to our Fireware and SmartPhotos platforms. So you'll see more about what that means. We're going to start off by cloning some repositories. Now, I'm going to delete this because I already installed this here to test, but let me install this again. So we clone this Computate_project Ansible role for installing Java projects that want to generate code for them using the Computate project. So we have that installed. Next, we're going to clone the Computate project. And I'll explain this one in a sec. First, I'm going to start compiling the code in the Computate project with Maven clean install. The Computate project is a Java project that watches for changes in files in a directory recursively. And when it senses that a file has been created or changed, it parses the Java code and indexes every detail about that Java class, including individual records for each constructor, method, and field into Apache Solar search engine. And it generates code based on what it discovers in the search engine. So this is the main open source library that does the AI/ML code generation. Instead of a typical model server, we use Apache Solar as the model server. We can flexibly index every aspect about our Java code in Solar as we code over time, including multiple Java projects at the same time and link together classes, types, and foreign key relations between projects. Pretty cool. So this has installed correctly. Next, we'll clone the Computate search project, and we will install and compile it next. While that's running, the Computate search project is a Java project that mainly interacts with Apache Solar to make search queries and parse the response. There are also several datetime serializers and deserializers for handling datetimes in requests. And one other important class is the wrap class, which can wrap a Java field initialization value by its generic type as part of a generated initialization code for each class. So this is building the source code so that we can do powerful search functionality in our site. So that is done. Let's take a look at how the Computate search project is configured locally. So it knows where the source code is in our workbench home directory /computate-search, and it's connected to Apache Solar in our OpenShift project here. And let's find out what Apache Solar knows about this Computate search project now, because we just actually, we're going to index every Java class in Computate search next and store it in the Solar search engine. So let's see what happens. Right now it's indexing the search tool, .java, time tool, XML tool, Solar response, wrap, and all of these serializers and more. Now it actually goes and repeats. Now it's indexing the search tool again, and I'll explain why in a second. Let's find out what Apache Solar knows about this Computate search project. We run this Solar query, and it says that the Computate Search project has 14 Java classes, one that's named Computate ENUS class, one called Search Request, Solar Response, Search Tool, XML Tool. It has one constructor, has 374 methods, like deserialize, parse math, serialize, 177 fields, like zones, date, time, formatter, calendar units, default map, TZ, and 30 new generated fields, cursor mark, distance, distance units. Generated fields are initialized by asynchronously to give you an advanced way to put values in a class. Sometimes you need to update one field based on another, like a calculated field, and it's really easy to do that thanks to the code generation that we put in to these projects. Really easy to extend. So next we're going to install another project called Computate-Vertex. Vertex is an asynchronous programming language built on Java that lets you do reactive code. You've also may have heard of Quarkus, and the asynchronous nature to Quarkus is actually Vertex under the hood. So we're going to use Vertex to build our APIs, but first we need to install the project. So while that's installing, this Computate Vertex project is a Java project that integrates the Vertex libraries into a project for reactive, event bus-driven software development. There's additional search capabilities built in to perform searches to Apache Solar asynchronously. And there's a PostgreSQL database integration with serializers and deserializers for GeoJSON fields to put things on maps. Additional Vertex tools, OpenAPI schema writers, boilerplate code, project writers, Fireware and NGSI LD context writers, OpenAD Connect OAuth2 authentication and authorization handlers, handlebar HTML template handlers, and a base API Java interface for building powerful, reactive, secure APIs for anything. So we ran this installer, and now we can take a look about how Computate Vertex is configured. It's here in the source directory, and it's connected to Solar now. So we can index this project now that it's installed to Apache Solar. So it's going to start indexing these classes here. And you'll see that it hit an error. That's okay, because sometimes there's classes that relate to something else, and it doesn't know about that class yet, and it throws an error saying that it couldn't find a class that it expects to find. But on another round trip, if we look at the logs here, it reindexes each class a second time and then a third time. So think about it. If this class doesn't know about this class, and this class gets indexed the first round, and then this class gets indexed the second round, well, they both get indexed the first round. But then if this class needs to know about this class, then you have to index it a second time. And sometimes we index it a third time because something new gets written to a class. Like when there's foreign key relationships, this class doesn't know about this class, and so you generate the code for this one, and then you generate the code for this one, and then you need to regenerate the code for this one because it does the final link of that foreign key relation to each other by generating that code 3 times. It's a little confusing, but it works, and it's fast enough that it doesn't cause us any problems to reindex 3 times. It's beneficial. So we've indexed all of those classes. Let's find out what Solar knows about the Computate Vertex project. it says that there's 34 Java classes, 7 constructors, 254 methods, 238 fields, and 360 new generated fields. Next, we're going to install the Smart Village platform. We need to clone 2 repositories, Smart Village Platform and Smart Village Platform Static. Static is full of JavaScript. It's also it's mainly just JavaScript. Yeah, this I'll tell you about more static files later on in the following project. So we install this project with the Ansible playbook here. The Smart Village Platform project is a Java project that integrates the Computate Vertex and Computate Search projects together with additional tools for smart cities. There are helper classes for working with latitude, longitude coordinates, angles and directions of vehicles, map results, models, search engine results, articles, page layouts, site users, and it manages the package deployment of new releases of new versions of the Smart Village platform. So this one takes a little bit longer to compile. And that's what it's doing right now, is building the source code. So we'll just wait till this is done. Now it's done. Excuse me. It's done building the Smart Village platform. Let's take a look at its configuration. It's got a few other unique values in this one for authentication. Let's index all of the classes for the Smart Village platform. Don't worry about this error. It's going to resolve over time. There's 2 errors, 3, 4, 5. But then you see here that it's starting to resolve, but here's some more errors that it caught that the site user is missing. But later on, it managed to index everything successfully, and now it's done. So that's a good sign. Now we will ask Solar what it knows about the Smart Village platform. And it says there's 24 Java classes, 4 constructors, 61 methods, 73 fields, and 253 new generated fields. Next, this is the last project we're going to install, which is Smart AI or Smart Village. This one has additional static resources that include the Fireware context data. It's basically a description of every smart data model that we've put into the system and every field for those smart data models. It writes the documentation for all that smart model context data into this project. We need to get this cloned, those 2 repos cloned, and we need to get this playbook running because this one takes a little longer. It's got a lot of code in it. But the Smart AI Smart Village project is a Java project that integrates the Computate Vertex, Computate Search, Smart Village platform projects together with additional tools for the village of Veberad, Sweden. Our test village, we deploy smart villages or smart devices to the application based on Fireware smart data models like traffic flow observed and crowd flow observed to track vehicle data moving through lanes of traffic and count the number of people at a particular crosswalk or vehicles on a particular lane of traffic. We also build new smart data models like traffic simulation and smart traffic light to research, simulate, and prototype what a real smart traffic light would do and look like in the village of Eberroth. We also build simulation reports to adjust parameters and report on the performance of traffic lights in an area based on running repeated simulations. So that's what's going on in the SmartFire Smart Village project. We need to wait for this to finish compiling the code. Then we can move on. Okay, finish compiling. You can take a look at the site configuration for this project. It's got additional values, geo coordinates, and things that are useful. So we need to index all of the Java classes for Smart Village in Apache Solar. So we'll let it do its indexing. This one has a few more than the previous projects, a few more Java classes. And now it's done indexing. Let's see what Apache Solar knows about this Smart Village project. It says there's 38 Java classes, 4 constructors, 150 fields, 150 methods, 87 fields, and 423 new generated fields. The last thing that we need to install is all of Fireware's smart data models. We run an Ansible playbook below to clone the hundreds of Fireware smart data models and index each smart data model in Apache Solar. We search the smart model data when we create new Java classes to see if there is a smart data model. So we can add this code class comment to smart data model : space and then a search term, and that if that search term closely matches a smart data model, then it can generate the code for us to build that smart data model that we just have to copy and paste it, and then it'll go and build even more code, an API and pages and so much more to start working with that smart model data. It's all automatic. So this is something that takes a long time, about 45 minutes. So when this is done, we can continue.